Okay, welcome again to the part 2 of April preparation for the CCNA 200-301 exam preparation series. Part 1, the last one that was published 2 days ago, was had started discussing and solving 25 exam questions. We are also reviewing them. These questions that you might probably will face or see in the exam. This will give you a brief overview and an image about what you might see in the exam, type of the questions, how much time will each question take. As I mentioned before, that you'll have 2 hours if you are a native English person and an extra 30 minutes, like 2.5 hours if you were not a native English person. So at the maximum you will get like 2.5 hours to solve more than 100 questions, possible to be 105, 103, or even only 100, maybe 98. So to take it as an average, you'll have like only from 1 to 1.5 minutes for each question to be solved. This sometimes might seem like almost impossible or very difficult to achieve, or you might think that I will never catch that time, I will never be able to finish it at that specific timing of 2 or even 2.5 hours. But this is why this series is here actually, so that to prepare you and to give you an idea about how to deal with things, and also to avoid getting confused during the exam, because just like I've seen in the previous video and also in this video and in the upcoming videos, because each video will discuss like 25 questions only, 4 videos for April, maybe in May, June and July, whenever there is a new update, like for things that you might also see, they will also be published here. So anyway, like in every 25 question, you will see that some of the questions can be solved in like 10 seconds. It will be like asking for something very obvious, because you will study a lot and you will have one of the questions saying that which of the below pools, IPv4 pools or IPv4 subnets, is a private IP subnet, and it will be clear. You know what are the private IP addresses, and you will see the options that all of them are public, and instead except only one of them is private, so you will click it and go ahead directly. So this will take like from 5 to 15 seconds. That's good. Another question saying which of the following routing protocols is like an exterior routing protocol. In the entire history there was only one exterior routing protocol, which was called the Exterior Gateway Protocol, EGP, which was developed to become a border gateway protocol, BGP. So during one period of time, it was always one single protocol. So that's it. You will just navigate this protocol. There is it. Click it and jump to the other question. These types of questions do take from you seconds and might never reach up to 30 seconds of time. At the same time, this will offer, or this will like give you more time to solve other questions like subnetting, because you have seen some questions of subnetting like the DND that we solved in the previous video can take up to 10 or 12 minutes in the exam. So practicing subnetting a lot for a lot of examples before you enter the exam will help you a lot for that, because especially if you should, it's not even especially, but you should do it on paper by yourself. Okay, so you need a pen and a paper, and you will need to do a lot of subnetting and calculations and conversions from binary to decimal and vice versa. This will help you a lot. If one question used to take 10 minutes before, then it will take like 2 minutes. And yes, this will happen. And even in the future, when you keep practicing, you will memorize them. You will start to memorize subnets, and you will find subnets look logical just from the look, without even the need to do some subnetting by using paper and pen and paper. 2 more notes before we start this video, and also before we start solving new questions. Another 25 question here today. Cisco, one of the only, or maybe it's the only vendor, or maybe it's one of the rarest vendors in the world that their online exams do not accept to go to the previous questions. They do not allow for back navigate. You will only proceed forward. Once you solve question number 1, that's it. You will jump to question number 2 and you will never be able to go back. Other vendors do accept that, actually, do accept you to go back and forth how many times you want. Do accept you to flag any question that you'd like or tag it so that you'll review it later after you finish the exam. So even if you try to finish the exam and hit submit, it will take you to another window saying that before submitting for real, there are some of the flagged questions that you might wish to review again before you do a second submit for the exam, before calculating the score. This is not how it's happening with Cisco. With Cisco, you will only go forward. That's it. Question number one, pass, 2, 3, 4, that's it, and you will jump. So the point of this is that also when you see a question that's very difficult, if you were able to navigate forward and backward, then you will leave it immediately. Go and solve another questions, and you, after you refresh your memory, or maybe another questions will help you to refresh your memory, will remind you of some concepts or protocols, you will go back to that question and solve it. In Cisco, you cannot do that in Cisco's exams. So try to answer the closest reply, or the closest answer to the correct one that you think regarding any question that you don't know how to answer it, and jump. Don't waste time. What I mean is that do not waste time. Do not think that if you gave this question 10 minutes, you will figure it out. These 10 minutes will kill a lot of time because you have 100 questions to answer. So leave it. That's it. If you think that maybe it was like answer 2, one of them you are sure of it and the other one you are not, answer any 2 replies, one of them you are sure of it, the other one might be incorrect, and jump to the other one. Yeah, you have to do that. I know this is not the best scenario, this is not the best solution that you can do in the exam. This will make you lose the full score of 1000 out of 1000. But remember, you need to score 825 score to pass. This doesn't mean that you need to collect 825 score points, actually. I haven't mentioned that also in the previous video. What Cisco does is that it says that you will need to reach a minimum score of 825 points to pass, but actually we will give you a gift score, which is 300 points to start with. So on a scale, you will start to collect points from point number 301 up to point number 1000. So if you want the number to be more realistic, or what's really happening behind the scenes, is that you do not need to collect 825 score point to pass. You need to actually to collect 525 point in your score to pass. So it's almost like half what you need to collect. So you can measure it this way. You can also measure it another way, saying that I can only lose 175 point before I reach the lower threshold of 825 out of 1000. In both scenarios, do not think maybe you can avoid things this way. You should only concentrate on the exam, because you cannot distribute the marks and points. You can only focus on your questions, solve as much as possible you can, try to finish all the questions, and you will. Don't worry, I'm not saying that to frighten you. It's not this way, because I have seen, like, so far for now, more than 10 people's only in Feb and March, which are the first 2 months or first 5 weeks of the exam age, have passed with a minimum of 800 and something out of 1000. It's not even, I'm sorry, 900 and something, not even an 800. So yes, they are scoring good scores, and as you see in the previous video, we solved like 25 questions. Almost 22 of them are directly mentioned in the slides of the course, and I have already talked about them and discussed them. So the questions are sensible. You can see that they make sense, they are mentioned before, but at the same time there are other questions, because in the official blueprints of this exam, Cisco leave a small note below in the blueprint in the PDF file, saying that you might also face some some questions in the exam that are not mentioned above in the blueprint. So yeah, it's really tricky, especially with Cisco. It's extremely tricky sometimes. Might be. I have one of the exams like that one in the corner up. It was the CCNP design, or actually it's called the CCDP, the Cisco Certified Design Professional. that needs to achieve this certificate you needed before. Right now it has been completely deleted and replaced with an enterprise design specialist, but before it needed you to pass the CCNP route exam, the switch exam, and the arch exam. The route and the switch exam, both of them I had them already because I was already certified as a CCNP routing and switching. For the arch exam I failed it twice and not barely actually, I scored 916 almost in the third attempt. So that was because actually of some questions that were not mentioned in the blueprints of Cisco. A bit of questions were not mentioned at all in the official study guide, in the book of Cisco. Sometimes these things do happen. And in my third attempt, when I passed the exam, actually I faced questions from the CCDA exam and from the CCNA security exam and from the CCNP route exam. So just because I was lucky and I was already certified in all of these three exams before, they really helped me in passing the arch exam, and that's why I failed twice in the beginning and then I scored 900 and more than 900 point in the third attempt, and I passed it at last. Like it cost $900. So anyway, that was just to make you expect, because this series is all about to make you make you prepare, or prepare you actually to prepare you to have a full imagination about what you might and what you will face in the exam, because I want you to expect everything and to expect the worst scenario that can ever be, so that in the exam when you do not see the worst scenario, you will be comfortable and you will not be confused, and you will think that okay, so far we are good. This is better than going very optimistic to the exam and think that they might be only 50 questions of things that are directly mentioned in the book or in the course, and that's it, I will pass in 30 minutes. And once you see question number 4, which is something that's not mentioned in the exam, like something about EIGRP or VTP or BGP, you'll feel like, am I in the wrong exam? Have I failed? I will no longer can do that, because such things do happen. And also for me, when I first started my 3 years ago, I first started my January, my journey with the CCNP certificate. My first exam was the CCNP route. I failed it because I have left two topics that I have not studied, which were the URPF and the BFD. So I failed with really the worst score that I can ever achieve. So a few days later, after I've studied again and studied these two topics again, I have entered the exam, and I was very anxious and confused that this time I must pass. I've already lost a lot of money. The first thing that I started is that there was a tutorial, and for you to prepare you and introduce you to the exam and what you should do, what you should not do, what you will expect and what you will see and face during the exam, etc. So I kept next, and one of them was something the same interview, and I hit next, and then I have look at the edge, the right corner up on the screen. I see that the count is right now 2 out of 60. So I have passed a question without knowing, and that question was a lab, and labs do have 10 times of score weight more than normal questions like MCQ. So I thought that's it. I killed almost the entire exam with one click before I even started. So I had to take my entire 2 hours, my entire 2.5. Actually, I did take a complete 2 hours at that time, just to carefully answer each question. And the good thing that I passed it later. I'm sorry. I passed it. I've done it. That's it. Yeah, and that's it. So without further talking, I believe that should be enough for an introduction, just because of some notes that I did not mention in the previous video. I have seen some comments and they were good regarding the previous video. Actually, they were a little. Few comments, not little. But anyway, we should complete the series. So for the second part, we will discuss another 25 question today, starting from question number 26 up to question number 50. Now these questions will be Question 26 saying that what is the primary effect of the spanning tree portfast command? In the middle of chapter 2, when we talked about layer 2 technologies, there were two types of ports in the end that you can do to your switch ports in your network, in your spanning tree network. One of them was called an edge port, which is a port that once you make it an edge, it will get out of the election of spanning tree and the spanning tree will not see it. So it's out, that's it, finally, and will not go through those elections and 50 seconds of elections, that annoying 30 up to 50 seconds delay elections time of the spanning tree. The other type of ports was the port fast. Port fast was like for a port that will still in the boundaries of spanning tree, but will go past the elections fastly. It will not go through the elections, but it will stay in the spanning tree, in the tree itself. Okay, so this has some uses, like to for a direct server, that you know that it will not cause you a loop in the future. Like you need to apply the port fast for some guaranteed ports, because once they are not in the elections and they are accepted, maybe they will cause a loop, maybe they will send a broadcast message, etc. Maybe they will cause some storm. So you need to be careful when you use the port fast. So saying that, what is the primary effect of this port fast command? The possible replies or the possible answers will be number one, or reply answer number A. It's not number. Answer A is it immediately enables the port in the listening state. No, it will directly work. It immediately puts the port into the forwarding state. It will immediately work. Listening state take 15 seconds. Forwarding also take. No, I'm sorry. Listening is do not take a lot of time. Learning is the one that's taking 15 seconds, and also forwarding, but both of them do take time before the interface goes up. And port fast make the port goes up almost immediately. It enabled some BPDU messages. Any interface of the switch is already using the BPDU messages, so it's not something new for the port fast. It minimizes the spanning tree convergence time. See, so this will be faster. Okay, port fast will be much faster to engage with the spanning tree, and thus you'll be welcome to the family of the topology. Okay, so I will go with D, which is minimizing the convergence time of the spanning tree. Question 27, which result occurs when port fast is enabled? Good, the same question, so we are having from chapter 2 more. Previous video was mostly all about chapter 1 on subnetting, cables, etc. Which result occurs when port fast is enabled on an interface that is connected to another switch? I'll just say that port fast may be enabled to some interface that heading to a server. By server I mean an end device, and this might also be heading to a customer, etc. But heading to another switch in my topology. A. Root port choice and spanning tree recalculation are accelerated when a switch link goes down. No, this is not related to relations between and elections between two switches. This is not related for the bits that will be changed and sent, which is called the acknowledge bit or the TCP. I believe, no, it's not the TCP. It was the acknowledge bit actually that should be sent between inside a BPDU frame between two switches. This will not affect that at all. After spanning tree converts successfully, port fast shut down any port that receives BPDUs. I believe that was called the BPDU guard, not a port fast. There is such thing that you will study in the CCNP, I believe. There is a BPDU filter, BPDU guard, root guard, etc. Port fast, of course, port fast will not shut down any interfaces. VTP. Cisco do remove VTP from the blueprints, but they also might mention in the exam. Things happens. VTP is a VLAN trunking protocol, and I believe one of the upcoming questions will be specific regarding the VTP. So I will talk more about the VTP protocol in that question when we read that question. So VTP is allowed to propagate VLAN config information from switch to switch automatically. Portfast has nothing to do with VTP. I hope that answer D is correct or makes some sense. Spanning tree may fail to detect a switching loop. As I said, you need to be very careful before enabling port fast to an interface, because that interface might be connected to another switch, and it's not right now. It's connected to another switch and might receive some broadcast domain from that, broadcast message from that, or broadcast storm from that switch, and will definitely cause you a loop. And the network that causes broadcast storms, and broadcast storm is a switching loop. This is the same meaning. Both of these have the same meaning. So answer D is good. Okay, actually it's the only answer that fits this question. Question 28 looks like simple, maybe not. Which quality of service profile? Quality of service profile, I have not mentioned that in the course, unfortunately. Because the blueprints did not mention that, is selected in the GUI when configuring a voice over wireless LAN deployment. Okay, this depends on the deployment part, like creating and configuring the quality of service profiles inside the wireless LAN. By saying GUI, I believe it means both the GUI of the wireless controller, WLC, and also the autonomous access point, the APs. So that should have been deployed in those devices and the wireless LAN devices, but unfortunately the Cisco Pack Tracer, which is the only free software that we can use for setting wireless LAN, I've navigated this software a lot, but I did not find any of the wireless LAN devices that do support applying quality of service, security, or AAA profiles inside it. So because I believe it might be in the upcoming updates of the software, but so far it's not. So for this question, I believe I did some researches and I found that some sites mentioned that it might be the platinum platinum profile that you need to apply in a GUI of a wireless LAN device when you configure voice over the WLAN deployment. So you can go right now with the platinum, and I believe this is the most correct one. Question number 28. Just in case we had we will able, maybe if I had some real devices from Cisco, some live gear, then we would definitely have a good answer, a definite answer. We can connect to that device and see, just like we do with routers, switches, and PCs. But for wireless devices, they need to be even more developed in the pack tracer. Okay, so question number 29. Refer to the exhibit, and this is the exhibit of two switches connected using gigabit Ethernet ports, and each switch is being accessed to a VLAN. Okay, both of them are in the same VLAN, so this is an entire one broadcast domain. After the switch config, the ping test fails between PCA and PCB. Let's see why. Based on the output of switch 1, which is this one on the left, which error must be corrected. So what this thing means, actually, the exam want to tell you that switch number 2 has the correct config. This should not be changed or edited. So we need to compare switch 1 to switch 2 and see if there is some mismatch in the config. Maybe both of them are going to enter the same interface. Switch port enabled, administrative mode trunk. This is between the two switches. Okay, should be trunk. Operational mode also trunk. The encapsulation is .1q, thank you. Also the operational is .1q, good, because it's for trunking. Negotiation of trunking is off, that's it, it's already enabled. The default VLAN is 1, good. The trunking native mode VLAN, the native VLAN is 1, and right here the native VLAN is 99. So this is the correct one, and here it's VLAN 1, so this should be changed to 99. This is the first thing that to notice. Administrative native VLAN tagging enabled, of course. Native VLAN tagging enabled. Native VLAN should not be tagged, actually. But anyway, maybe this is through the trunk ports. Even so, should not be trunk. Okay. Output omitted, trunking VLANs enabled from 50 to the same, all of them the same. You can see that by comparing the config between the two switches, the question is saying that this is the correct switch, and from this one we should correct this one, and I see the only difference is that this config needs to be changed. The native VLAN should be 99, not 1. So PCs are in the correct VLAN, incorrect VLAN, no. All VLANs are not enabled, no. Access mode is configured on the switch ports. I know they are trunk between them. There is a native VLAN mismatch. Yeah, that's clear. That's the only thing that we can, or that we could obtain from this interview, that we can see from this, this exam view. Okay, good. So I drag and drop. Let's wish for the best for this question. Question 30. Drag and drop the wireless LAN components from the left into the correct description of them on the right. I believe that most of them, maybe it's all of them, I have already mentioned them in the chapter 6. So an access point. An access point is the device that your mobile phone, your laptop connects to. So an access point is a device that manages access points. No, a device that provides Wi-Fi devices with a connection to a wired network. No, this is the distribution system. This is a switch. I've talked about this before. A DS used for out-of-band management of a wireless controller. I don't know what this component actually is. Let's see, but definitely not. Used to support mobility management of the WLC. No. Applied to the wireless LAN for wireless clients communication. Applied to the wireless LAN for wireless client. I'm not sure. If there is no distribution system here, virtual interface, dynamic interface, service port, controller. Yeah, there is no distribution system here. So we can consider access points as one of the components that connects you to the wired network, because yes, it does make sense, but just in case DS was here, which is the distribution system, or a switch was here, then this is the point that connects the wireless LAN to the LAN. So since there is no distribution system, access point can be considered one of the components that can have, because actually if you want to, maybe if we look beyond, or maybe if we look closer, not closer, even further, then we will see that an access point will already have a cable connected back to a switch, and that switch is the DS that goes back to the LAN. So access points, actually, they do connect you to the wired network. A virtual interface, let's say it's one of these two. It's used for out-of-band management for WLC, or used to support mobility management of the WLC. Actually, these are three types of different interfaces, and I should use all of these, because wireless LAN controller is the one that controls the access points. So we are done. So we now have these three that we should connect them to these three. So there is a service port, a dynamic port, and a virtual port. Port and interface are almost the same. So used to support mobility management of the WLC. This is the management port. And it's also called the service port, yes. Let me check one thing, because I did mention that in the slides of chapter 6. Since this is a preparation, then we can cheat a bit and go back to the slides and see that wireless principles, not here. These are wireless. This is the DS that I talked about, the wired network that connects the access point to the LAN. That's why I thought that the DS should be there. It's about channels, architecture, positioning, convert, access point modes. No, they will not mention the ports of the WLC. I believe here. Yeah, definitely should be here. Some access points have some auxiliary and PoE. Yeah, thank you. WLC have a service, or called also a management port, that can have an IP address assigned for GUI access. Okay, good. So this port, the service port or the service interface, is used to access the device, to access the GUI of the device, but it's not remotely. Okay, so we can use that for another option. And okay, this one also will not make use. Okay, so let's go back to the question. And heading to support mobility, out of band management applied for the communication. Okay, so this will be the service port will be the one that is responsible for the out of band management. Just allow me to reset my pad because I feel that its behavior is not normal. Okay, yeah, now it's much better. So the service port will be responsible for the out of band management, okay, to access the device. Dynamic ports and the virtual interface apply. This one is used to support mobility management, and this one is applied for the wireless LAN for wireless client communication. I will give the dynamic interface up to this one, and the virtual will be for the mobility. Okay, I'm 90% sure of all of this. You can further navigate it, okay, but for me I'm sure of this, okay, and I hope you will. This is for question 30. For question 31, which unified access point mode continues to serve wireless clients after losing connectivity to the controller? The lightweight access points do know nothing and do behave nothing and have no brain, no decision, no control at all. Everything for the lightweight access points, which are the lab, is done by the controller. So once the controller goes down, or the tunnel, the CAPWAP tunnel between the access points and the controller goes down for whatever reason, those lightweight access points will disconnect all their clients that are connected to them and will sit there like a dummy. They will do nothing. To solve this, Cisco produced another operational mode. Actually, I've mentioned that twice in chapter 6, so you'll find this method, the term that I will use right now, twice. They developed another operational mode inside those lightweight access points, not for the autonomous access point, for the lightweight access point, which is the Flex Connect operational mode. This will allow the lightweight access point to take the instructions first from the wireless controller, and just in case wireless controller went down or the CAPWAP tunnel went out for whatever reason, the access points will the lightweight access points will continue functioning normally. They will not disconnect the devices, the clients connected to them, and they will not become dummy. Okay, so Flex Connect will solve this big issue of the lab, the lightweight access point, and that will be C. Okay, question 32 says, refer to the exhibit. This is the exhibit, and I can see in the exhibit the command is not there. Okay, this is the trick then. Which command provides this output? Yeah, okay. So one of these commands do provide this output. I can see that this is the legend of some codes. This is my device ID. This is a local interface. This command you have used before. If you watch chapter 2, you'll find this command definitely in a lab. Okay, but I will not say the name just in a few moments from now. Some interfaces and also some platform seen for the opposite device and the interfaces of that opposite device. So this is one of two. This might be one of two protocols that do show you your neighboring devices and their information of those neighboring devices. And it's either the Cisco Discovery Protocol, the CDP, or Lightweight Discovery Protocol, which is the LLDP. So let's see the options. Show IP allowed, definitely not. No routes are here. Show CDP neighbor, possible. Let's see, I do not recognize CDP and LLDP differences, but for now we can see that this is a CDP. Show IP interface, no interfaces are here. Show interface, definitely not. No physical informations are here. So without taking a complete minute inside the exam, 20 up to 40 seconds might solve such question. Because if you did the lab of CDP, and also you have seen the LLDP. I'm sorry, I believe the lab was only for LLDP, or it was for CDP. Maybe we did both, I don't remember, but we did such lab in chapter 2. Then you will know that directly when seeing this table, you know, oh, this is a neighboring table, and that's it. So you will not have to waste a complete minute or two for such question. So it will be B. Okay, question 33. Which mode must be used to configure an ether channel between two switches? Okay, it's either LACP or PACP, but the mode depends on the protocol without using a negotiation protocol. In the end of chapter 2, when we issued the command of channel, pardon my handwriting, channel group 1 mode, and we hit the question mark, there was 5 options below. Option number 1 would be like active. This is for LACP. Option number 2 would be auto. This is will be for the PACP. Option number 3 was on, for no protocol negotiations. Option number 4 would be passive. This is would be for the LACP, and the final one would be desirable. This is also for the PACP. So 2 for the LACP, 2 for the PACP. Only the on is for no protocol negotiation. So that is on. Thank you. All of those are incorrect, and you can make sure of that from chapter 2 and the lab that we did. So that would be also B. Okay, on. Question number 34. Which mode allows an access point to be managed by the wireless LAN controller? This is the lightweight, because an autonomous access point will never allow for a lightweight, for a wireless controller to control it. It controls itself. It have a really strong, heavy and strong software and reliable software to apply everything, all the profiles, quality of service, AAA, security, etc. Also to do the encryption and so on, and it can connect itself directly to the distribution system and go back to the LAN. So it will never be an autonomous one. Mobility Express is a solution from Cisco. This is not the point. A bridge, which is another operation to bridge 2 wireless access points together, but lightweight will be the one that allows for an access point, for a wireless controller to control it. And we have just mentioned that a few questions ago, and many times it was mentioned in the chapter 6. Okay, so that would be answer B. Okay, question 35. I believe we are going good so far. Question 35, let's see the time. Yeah, question 35 says, which 2 values or settings must be entered when configuring new wireless LAN and the Cisco wireless LAN controller GUI? So when you're having a GUI and you want to create a wireless LAN, wireless network, a Wi-Fi, you want to start streaming Wi-Fi. So what are 2 mandatory things that you must, they are not optional, they must be there for your Wi-Fi to work? A, quality of service settings. You can make everyone welcomed, so quality of service is not mandatory. B, an IP address for 1 or more access points. If it was a controller, then I don't believe that you will need an IP address for each access point. I believe they will be no, I'm not sure. Let's go back to this again, but I believe that you will need an IP address for every access point, because this is how a wireless controller will see them. Actually, if the packet tracer supported more flexibility with wireless, then we would do that. Anyway, an SSID, of course, how would you stream that? A profile name, which is the name of the network before start streaming a Wi-Fi. Yes, so we have reached 2, but let's see if more are specific. A management interface setting, not mandatory. No, it's not mandatory for the moment being. So I'm sure of the SSID and the profile name. I'm not really sure about that, but since those are good, then I should not waste the time of the exam by overthinking, because I do have 2 answers. Sometimes they might be tricky. Sometimes Cisco might give you 3 answers, 3 correct answers, but it says choose 2, so you'll have to choose 2. Maybe this one is correct also, because I doubt how can the access points do, the lightweight access points do communicate with the wireless controller if they do not have an IP address. Okay, so we'll go with the C and D for now, and maybe we should navigate furthermore if this was correct, mandatory or optional. Okay, so that would be C and D for question 35. Question 36. Which command is used to specify the delay time in seconds for LLDP to initialize on any interface? Okay, then we can delay the initiation of LLDP. That's a new information. It's either LLDP timer, LLDP TV, TLV select. No. TLV is another protocol. LLDP reinitiate might be, or LLDP timer, LLDP hold time. We can maybe navigate the official cert guide of Cisco. We might see such things there. Okay, so we're heading to the official cert guide from Cisco for the CCNA 200-301. This is volume 2 actually, that was talking about the LLDP. by looking for the that was about, yep, LLDP. Thank you. There will be an entire chapter for LLDP on page 190. Go there. Okay, these are some commands. The question was about a reinitiate. Show LLDP interface initiation, reinitiation. Reinitiate station is delayed for 2 seconds. Can we do that? Okay, no more. Previous attempt will be only this one for reinitialize. So you can override the defaults with the LLDP timer. Okay, so LLDP timer to override the defaults, not to reinitiate, and LLDP hold time also for this cause. And let's see, the command was, I'm sorry, 1 minute. So it's not the timer or the hold time. I'm sure it's not the TLV select. So LLDP reinitiate. Let's see if there is such command mentioned in the book. LLDP reinitiate. Okay, so there is no such command. Okay, things do happen for Cisco. Anyway, that is LLDP run, of course, to enable LLDP because it's disabled by default, not like the CDP. Show LLDP, LLDP run the whole time, and the timer are not for the initial reinitiate. TLV is definitely not for the reinitiate, so I will take reinitiate the LLDP reinitiate for that. Okay, so specify the delay. These were to restore for defaults. And second, to initialize on any interface. And just make one last thing to make sure of. This is not for playing. The default settings is 30 seconds and 120. You can override the defaults with the timer. Okay, so the timer is not to specify, it's to override. Okay, and hold time global respectively. Okay, so those are for overriding, they are not for specifying, so I believe the reinitiate will be for respecifying, to specify delay, because these two will be used simultaneously together to reset for default timers, but the reinitiate might be used for another one. Maybe the Cisco Packtracer do support that. Just in case it did not, then you have to use another emulator like GNS3 or Eve. So let's continue with question 37. Question 37 says that refer to the exhibit. How does switch 2 interact with other switches in this VTP domain? Cisco had officially removed the VLAN trunking protocol, which is the VTP, from their new exam blueprints. Yet they are mentioning it, and they also did mention it in the previous exam, the previous questions. So you might see the VTP and you might not in your exam, but just in case you saw it, VTP in a nutshell is a protocol that has a username, domain, password, version, such configs that you need to specify within a group of switches, just like this way and also this way. So you'll need to copy and paste the same config, except for the mode you will change it, whether it was, I believe the names were like a server, client, and transparent, and there was even a master, which is above the server functionality or operations. So basically there were master, transparent, and client. So what they will do is that from now on you will only add new VLANs or remove an existing VLANs from the VTP server, and this server automatically communicates with the transparent and the clients, or specifically with the client, saying that you need to update your VLAN table, your show VLAN brief. So this is all what this is all exactly all what this protocol does. So switch 2 says that VTP domain Cisco, this is a name that should be copied and pasted between all the switches. It should match. VTP mode transparent. The transparent will received a frame or a BPDU from the server and will bypass it to the client directly. It will not be affected by changing VLAN, by removing or adding a VLAN. Okay, so it seems that this switch 2 is a transparent, so we can consider this switch is switch 2, it's transparent. The password, which is Cisco test, this should be copied and pasted and identical between all the devices. And then interface number, etc. So the interface will not affect that. Okay, it should be encapsulated trunk, definitely, because it will allow for the VLANs to cross. So switch number 2 is a transparent, so it will only transfer those settings from the server to the client. So A, it transmits and processes VTP updates from any client on the network to its trunk ports. Let me see. B, it processes VTP updates from any VTP client on the network to its access ports. No, it's not about processing from port to port. It's about changing the VLAN table. It receives updates from all VTP servers and forwards all locally configured VLANs out all the trunk protocols. Mostly, it forwards only the VTP advertisement that it receives on its trunk protocol. No, I will go C, because it's not about like changing an effect or something on the trunk or the access, but it receives updates from all the VTP servers and forwards locally configured VLANs I'm sorry, out of the trunk protocol. Yeah, I believe this will be this one for question 37, because the transparent do nothing. They only receive the updates from the server and bypass it to the client. A and B will definitely be incorrect, but for D, it forwards only the VTP advertisement. C says what? C says that receives the updates from servers and forward locally. Yeah, because you will not assign a specific interface for VTP. VTP will be globally configured. It will not be under interface. I will go C, and I'm sure about that. I will go with C for that. So it forwards only the VTP advertisement. That's zipped on the trunk. Of course, it will be trunk. It's only about changing the VLAN table. So I will go with C. Okay, for question number 37. Okay, so without further wasting of time, let's go for question 38. And question 38 says that refer to the exhibit, which is show LACP neighbor. Okay, based on the LACP neighbor status, which is the neighbor guy, which mode is the switch one port channel configured? So it's LACP, so it's either active or passive. But based on the neighbor, let's see if the neighbor is active or passive. Show LACP neighbor. This is the flags, the legend. And I see that there are two interfaces included in this one. They have two flags, S and P. S stands for the device is requesting slow LAC PDUs. Leave this one, ignore it. P for device is in passive mode. Then that's it. The question has been solved itself already. Because it says that your neighbors, which are Ethernet 1.0 and Ethernet 1.1, are passive. And since LACP is showing interfaces here, means that LACP is operational right now. It's working and operating right now. And since LACP is operating and the opposite side are passive interfaces, then my interfaces are definitely will be active. So my interface is active because you will need at least one of the two sides to be active. So it's either active passive or active active. Since the other side is passive and since LACP is working, then I'm definitely an active. Okay, so I'll go with B, which is active. It's not on because there is a LACP. It's not passive because if the both of us are passive, we will definitely not work. It's not auto because auto is for PACP and we are talking about LACP. Okay, so it will be B for question 38. Question 39 says that two switches are connected and using the Cisco DTP, the dynamic trunking protocol that I've used in the lab of trunking and also in the Mega Labs for the Arabic series. Switch 1 is set to dynamic auto and switch 2 is set to dynamic desirable. What will happen? Just like in LACP, good coincidence that we have talked about LACP or PACP, I'm sorry. DTP, since it's Cisco proprietary, just like have the same concepts of the PACP aggregation protocol, which is that when you have a PACB, two devices connected together using aggregation through PACB, then you will need both devices to be desirable, or at least one of them will be desirable. Okay, just like an active and passive. In DTP, it has the same concept and the same terms. You need both the devices to be desirable, or one of the devices at least to be desirable and the other be auto. Right now the question says that two devices, one of them is desirable and the other one is auto, and that's it. DTP will work correctly. So the link will become an access port. No, this is for trunking. The link is an error disabled mode. No, not at all, because it should work. The link is in a down state. No, the link becomes trunk port automatically, dynamically between the two devices. Okay, so that would be D for question 39. Question 40, we are almost at the end. Cisco IP phone again, like in the CCNA 200.125, there was a specific CCNA collaboration, yet Cisco mentioned IP phones in this exam, in the CCNA routing and switching. Right now, they have removed collaboration completely from the blueprints with everything regarding that and the VLAN voice, and now they mention the IP phone. Okay, an IP phone is like the local phone that you use, that was previously used in houses, but this one do not operate using the exchanges and using the lines of those lines that were used for transmitting before. It operates using an Ethernet cable, and the only thing that it needs is an IP address so that you can connect multiple IP phones together, and you need one router in the middle of them, and that's it. IP address, a router, Ethernet cables, and you'll have a network of IP phones that do talk together forever for free. Okay, so this is the big benefit of IP phone. So you'll see it inside banks and enterprise networks, etc. If an IP phone I'm sorry, receives an untagged data traffic from an attached PC, which action is taken by the phone? It drops the traffic. No, it's not a switch. It allows the traffic to pass through unchanged, or it does tag it. The port between the IP phone and the PC will be access port. Access ports do remove tags and they do insert tags, but will they insert the tag, or will they tag the data with the native VLAN or with the default VLAN? Neither nor. So I will take B, because they will not tag the native or the default, I'm sure of that. So it will allow the traffic to pass through unchanged. Yeah, that should happen. Why would there be a PC connected to IP phone? Because just from a matter of like making your network simpler and your cabling simpler, let's go out like for a few minutes and then go back. When you have like a section or a department in a company or a bank, you will see like these will be the employees, these will be their desks, their computers. Each employee will have a PC, a computer, and an IP phone to work and communicate with colleagues and managers, other departments, etc. What will happen is that for each department there will be a switch or a hub. It will be a switch, okay, for nowadays. So to give an IP address to your computer through DHCP, you will need to extend the cable to your computer, and for this little IP phone, it will only need an IP address, and you will also connect an Ethernet to this IP phone for this IP phone to be set as a DHCP for its interface, and this IP phone will also obtain an IP address. So this computer will operate in the network, this IP phone will operate in the network, and things are good. But there is another concept or another design says that Cisco IP phones, when you look at them from behind, when you pick one, you will see two Ethernet ports are built in this device. The idea is that you will need then to extend only one Ethernet cable from the switch to this IP phone, and to extend another short one to this guy over here. No worries, both of them will have different DHCP requests and acknowledgements, and both of them will be on the same VLAN, and the PC will be connected to the network through the IP phone. So this is only for a matter to reduce the amount of cables that have been used. That's why you will see that your Cisco IP phone will receive from a PC, receive a data from PC. Why is the Cisco IP phone connected to PC? For this reason. This Cisco IP phone is serving your PC and connecting your PC back to the switch and to the network. So this is what's happening in the enterprise and campus networks. Okay, so this is question 40. Let's head to question number 41. Which design element is best practice when deploying 802.11b wireless infrastructure? 802.11b is one of the generation of Wi-Fi net speeds, Wi-Fi speeds, okay, in bandwidth and transmitting, just like when we had like Cat1, Cat2, Cat3 up to Cat6, which these were category 1, 2, 3 for the copper cables. Each category comes with new interface speed or bandwidth in that supported in that interface. So 802.11b is just like that because there is an 802.11a, n, ab, b, ax. There was an AN or not, I'm not sure about that, but I don't think there is an AN. So talking about design for deploying an 802.11b infrastructure, let's see, allocation non-overlapping channels to access points that are in close physical proximity to one another. I don't know whether the updates of specifically of the channels used, but if it was a 2.4 gigahertz, then it will be 20 meg. And if it was 5 gigahertz, it will be more, up to 160. See what overlapping with that actually. Okay, disabling TCP so that access points can negotiate signal levels with their attached wireless devices. Let's ignore that. What does that have to do with it? Configuring access points to provide client with a maximum of 5 megabit per second. Actually, this is a new generation that should be supported by software and hardware automatically, so maybe it should be configured or maybe it should work by default. Let's leave that. Setting the maximum data rate to 54 megabits per second on the wireless LAN controller. Maybe these are some specifications that comes with the datasheet of this new protocol, but I will not go with them. What I will go with is that allocation non-overlapping channels to access points that are in close physical proximity to one another. Maybe because the 802.11b, when it came at its generation back in time, it came with a higher speed, higher bandwidth. Higher bandwidth means higher channel bandwidth. Higher channel bandwidth means, of course, definitely a higher bandwidth. Okay, so it's either 20 meg, 40 meg, 80 meg, 160, etc. So maybe it was a new generation and it had to allocate more bandwidth, and that more bandwidth will cause more overlapping. So you'll need to redesign your networks again, your Wi-Fi streaming, to avoid overlapping because channel bandwidths are now wider. Okay, so I will go with A for question 41, and hopefully that will be correct. Okay, so this is for question 41. For question 42, refer to the exhibit, which is show IP interface brief, one of the favorite commands. What does R1, which is me, use as its OSPF router ID? The definition of router ID, just like I mentioned in chapter 3, is the ID of this router, an entire ID that this router uses whenever it talks to another router using the OSPF LSAs. So you can know, or you can identify or modify the router ID by using one of two methods. Method number one, OSPF router ID can be already configured, so you can go inside the hierarchy, the config mode of OSPF, and make router ID is like 10.10.10.10. That's it. It will be permanent forever. This will be the router ID. Or you will leave the router to choose its own OSPF router ID, and that will be the highest IP address inside this router. Maybe your router has 4 interfaces, 5 interfaces, or even only 2 interfaces inside it. The router will compare each interface IP address and see which is the biggest IP address from a numerical perspective, and it will choose this one as its own router ID for OSPF. So here we have the 10.10.1.10, 10.10.10.20. So this one is smaller than. Oh, that did not happen in like the series itself. Okay, like in chapter 4. Anyway, okay, so option number 1 will definitely be not, because 10.10.10 is bigger, so it should be the biggest one. 172 is bigger than 10. Okay, so there is a bigger one. 192 is even bigger than 172, so this is the biggest IP address, the highest IP address available. But let's just check the exhibit because my eye did not catch that. Okay, so these 4 IP addresses are correct, and all of them are up, up, and the loopback definitely will be up. So good. So these devices are configured. These IP addresses are already configured there, and they are working. But the biggest one of them will be the router ID for OSPF. Okay. With electricity down, let's go for question 43 and see what we will obtain. When OSPF learns multiple paths to a network, it does it select a route? Higher bandwidth. Okay, so I hope you are seeing me right now in the dark, but it's higher bandwidth. OSPF is a link state protocol, so what it will do is that it will not take the shortest path. Funny thing is that OSPF stands for shortest path first, but actually its metric looks for the cost, for the lowest cost, and the formula of cost is 10 to the power 8, which is in megabits per second, divided to the bandwidth of the path. So the higher bandwidth, the lower cost, and the lower cost will be chosen to take it. So let's see the replies, or the possible answers. For each existing interface, it adds the metric from the source router to the destination and calculate the route with the lowest bandwidth. Definitely not the lowest bandwidth. It counts the number of hops. No, leave it. This is not a distance vector protocol. It divides a reference bandwidth of 100 megabit, which is 100 to the power of 8. I'm sorry, 10 to the power of 8, which will be 100 million. So it's 100 million bit, 100 megabit. By the actual bandwidth of the existing interface. This is the formula that I was just talking about. But let's see reply D, or answer D. It multiplies the active K values by 256. This one would be correct if we only replaced OSPF with E enhanced interior gateway routing protocol, EIGRP. EIGRP was a competitive protocol to OSPF, but the problem here is that EIGRP is lighter, faster, maybe uses less resources from the hardware of the router, but it was Cisco only protocol. It was a Cisco proprietary, so it works only on Cisco devices. The datasheet, I believe, was available in 2013, but so far it's known as to be the protocol of Cisco only. So this kind of protocols is called a hybrid distance vector protocol, and it uses this formula, which is 5k, which are 5k values multiplied, divided, and summarized, etc., and in the result will be multiplied again by the number 256 to give a very big matrix, just like 11 million and 39,000, etc. So this is how EIGRP looks like. But for OSPF, this is the formula of OSPF, so answer C would be correct, or definitely will be the correct one. Good. So question 44 will be, when a floating static route, which is the other static route that's hidden in the routing table that we had a lab on in chapter 3, is configured, which action ensures that the backup route is used when the primary route fails? How to configure a static route was one single command, one specific command of IP route this destination using this interface or this next IP address. To configure a floating static route, you will need to configure another static route, but with a higher administrative distance. The administrative distance of the static route was 1, okay, because the connected was 0 and the static route was 1. And you need to configure something higher than 1, like 2, 3, 4, 5, 6, 7, up to 10 or whatever. And that will make this floating static route become invisible in the routing table. Once this real static route with the AD of 1 fails, this one will pop up and show in the routing table and will be used until the original one will be fixed. Okay, so the administrative distance of the floating must be higher on the primary route. Never, it should be lower. The default information originate command must be configured for the floating. No, we had a lab, we did not use such command. The floating static route must have a lower administrative distance. Okay, already we have the primary one. This is getting boring. The primary one is already having an AD of 1, so maybe the floating will be lower. What will be that? 0.75? No. D. The floating static route must have a higher administrative distance than the primary. I agree. Okay, so that would be D. Thank you. Question 45. Okay, we are almost done, reaching question number 50. Refer to the exhibit. The exhibit is some information regarding the designated router, backup designated router. Yeah, good. These are something of OSPF that we have talked about in chapter 3. Show IP OSPF interface command has been executed on R1. How is OSPF configured? Okay, so there is a router ID for the DR. There is a BDR. There are the intervals. These are the default intervals, which are 10 and 40. Hello will come again in almost 8 seconds. There are some adjacencies to this interface with 3 adjacencies. One of them is the BDR already. Okay, a point-to-point network type is configured. No, I can see no point-to-point config in this interface. The interface is not participating in OSPF, it's participating and having 3 neighbors coming through it. The default hello and dead timers are in use, which is 10 and 40, that is correct. There are 6 OSPF neighbors on this interface. No, these are 3 and we can see that. So this will be answer C. Okay, thank you. Now, 46. A user configured OSPF and advertised the gigabit Ethernet interface in OSPF inside the interface. Okay, this happens sometimes. By default, which type of OSPF network does this interface belong to? Point to multipoint will not occur before you mention the command point to multipoint inside the interface. Point to point will not occur before you mention the command point to point inside this one also. So it's either broadcast or non-broadcast. The default behavior of this one is the same default behavior of any OSPF neighbor. I'm sorry, advertisement, so it will be broadcast. Okay, I don't know, it will not be non-broadcast, it will broadcast. This is the default OSPF config. So it's broadcast, that's it. Okay, for question 46. Question 47. Which attribute does the router use to select the best path when 2 or more different routes the same destination exist from 2 different routing protocols? What do make a router elects one routing protocol and relies on this routing protocol? Just like we have talked in the first 2 videos of chapter 3, it will be the AD, the administrative distance. So do not waste a lot of time for such type of questions. Jump in 10 seconds only. So it will be AD. But don't get confused. This is not about how a router decide to choose between 2 paths. This is I'm sorry, not about a protocol deciding how to choose between 2 paths. This is about a router to decide to choose between 2 protocols or multiple protocols. Like you can reach destination D by either using static route, EIGRP, or OSPF. But which one of those will take this mission and accomplish it? It will be the one that has the lower administrative distance. So it will be C for question 47. Question 48. Router A learns the same route from 2 different neighbors. One of them will be an OSPF neighbor and the other one will be an EIGRP. Okay, so just like the previous question, if there were 2 protocols giving you the same destination, which one will be used? This depends on the administrative distance of the protocol. So if your protocol was directly connected, it will be 0. This is for directly. Okay, this is not directly, this is a protocol. If it was a static, it will be 1. If it was an EIGRP, it will be 90. If it was an OSPF, it will be 110. If it was a RIP, then it would be 120. What we have is what we have right here is a competition between EIGRP and OSPF. The lower one will win, which is EIGRP. Okay, so I thought there will be some names here, but it seems that these are the ADs. Okay, so this guy will win. What is the administrative distance of the route that will be installed in the routing table? It will be EIGRP, and the EIGRP have the number of the AD of 90. Okay, almost done. 49. Refer to this exhibit. Okay. Oh, so there is MPLS here. Good. Is this a CCNP exam? Let's see. An engineer is linking up a new circuit to the MPLS provider on Gigabit Ethernet 01 or router 1. This is router 1, this is gigabit Ethernet 01. So there is an MPLS circuit configured between two of them. MPLS is called an overlay protocol, which is some type of advanced protocols that are used to manipulate the real route that used to happen before in the old days of OSPF and ISIS. Actually, MPLS is used upon OSPF and ISIS. I don't think it will ever be used upon EIGRP. So, guessing that you have an OSPF to connect these three devices together, or even BGP and OSPF are both can be used with the MPLS. So after you configure maybe OSPF and you have full reachability, you will configure the MPLS to even further manipulate the routing. Like maybe through this interface, this is a gigabit Ethernet interface, so it's 1000 megabit speed. Maybe you are serving, or there are passing here like 5 different types of traffic. Each one of them is going to a separate customer, VIP customer, a bank, ministry, network, etc. So you will need to isolate each one of them separately, and also you need to make each one of them have a different route. They are passing through the same devices, the same cable, but each one of them should route differently. This is how when comes the time to use MPLS. Okay, so there is an MPLS circuit that should be here. The new circuit is using eBGP, so it's either OSPF or BGP, just like I said, and learns the route to VLAN 25 from the BGP path. Okay, so from this path, what is the expected behavior for the traffic flow for route 10.10.13.0? Okay, so there is a 10.10.13.0 here, slash 25, this matches, and this is using OSPF 100 and 10. Okay, so this is using 100. I hope that the screen is big with you so you can see this table, and it's passing through gigabit Ethernet 00. Let's see. Traffic to 10.10.13.0 is load balanced out of multiple interfaces. Nope. Traffic is symmetrical, asymmetrical. I don't know. Route, this subnet is updated in the routing table as being learned from interface gigabit Ethernet 01. Let's see. And also route 10.10.13.0 is learned via gigabit Ethernet 01 interface, remains in the routing table. This is not acceptable. Traffic 2 from R1 to this one is asymmetrical. What you mean by asymmetrical means that it will go this way and go back this way. This is the asymmetrical behavior. The symmetrical route is that this subnet will travel forward this way and backward this way. Asymmetrical means that it will go this way and might go back from another way. So this means that for me R1 and you R2, I will send you 10.10.13.0 directly, but when you reply me back, you will reply me through R3. You will not reply directly to me. This is asymmetrical routing, asymmetrical route, and this is actually considered not a best practice and not preferred. Symmetrical route is always the one that should be preferred, because whenever the packets go for a request, it should be the same path to go back for a reply. So I can see that OSPF is using this one through R1, and yet it's establishing through MPLS and eBGP. So it's either B or D. I'm not really that expert in MPLS, but I will pick B. I will choose B. Not A and C, but I believe the traffic will be asymmetrical. I will choose B. Okay. That's okay. Question number last for this video. Which two actions influence the EIGRP route selection process? They remove EIGRP and then yet they ask you, okay, let's see if you will face such question in the exam or not. EIGRP uses a very complicated formula for calculating its best path, because EIGRP is a hybrid routing protocol, hybrid between the distance vector and the link state. So it makes the matrix of the RIP, which is a distance vector, and the matrix of OSPF and ISIS, which are link state, and generates a new complicated formula to choose always the best path, maybe the shortest and the higher bandwidth path. Okay, so this is how EIGRP works. So this formula contains 5 values, are called the 5K values. I believe they were like the delay of a port, of an interface or a path, the bandwidth, the reliability, the transmission and receiving, I believe, level or such thing. And there was also one fifth thing, actually, because EIGRP was removed here, so I did not study it, and I haven't worked with EIGRP for over a year so far. So that they were 5. 3 of them were not changeable, which are the reliability, transmission and receiving specifications, and also that third guy that I'm not remembering. But delay and bandwidth were changeable, so you can like manipulate or influence or change the delay and the bandwidth of an interface to make EIGRP thinks that this interface is better than another one, just to force traffic to go through such interface, through a certain interface. So let's see, the question says that which 2 actions influence the route selection process. Just like I said, we can manipulate either the delay or the bandwidth. A, the advertised distance is calculated by downstream neighbor to inform the local router of a bandwidth on the link. It's not about bandwidth only. The router calculates the feasible distance of all the paths to the destination route. Okay, I will not talk about administrative distance and feasible distance here. EIGRP is out of the scope. The router must use the advertised distance and the feasible distance as the metric for any given route. No. It's a complete complicated formula to be metric. The router calculates the best backup path to destination route and assigns it as a feasible successor. Yes. But yet, okay. The router calculates the reported distance by multiplying the delay on the existing interface by 256. Not the delay. Not only the delay. So it's not A, definitely not C, not E, D, the feasible distance to all the paths. The router do that, but it's not an influence. Okay, so I'll go with that. Okay, I will go the successor, feasible distance, administrative distance. These are specifications of EIGRP, and all of them will be mentioned in detail in the CCNP Enterprise course coming to this channel, hopefully. So B and D should be good, more than good, since A, C, and D are A, C, and E are completely mistaken. Okay, so this is the end of this video. I really hope that it was useful. I really hope that you did not get confused. This is a video for preparing and studying so that in the real exam it will be much easier for you and you know how to make use of the given time for you. So please, for any further comments, questions, concerns, you have the comments area below the video, and we can later after that in 2 or 3 days record another third part of this question video. So thank you for watching and hope to see you in the upcoming video. Goodbye.